To simplify a rational expression, what we need to do is take a look at the numerator and the denominator and see if there is anything that we could cancel out, right? All right, so look at this first example A. What I like to do is go first with the coefficients, then with each of the variables separately. So here, between the 27 and the 9, right? How could you simplify the 27 over 9? You can divide both by 3, right? And if you divide both by 3, you get a 3 on top and 2 on the bottom. All right? So here, that's going to be 3 over 2. Now, what about the x's? Oh, sorry. I'm sorry. We divide by a 9, so it'll be 3 over 1. Okay? Now, what about the x's? I have 2 on top, 1 on the bottom. How many will be left over? 1 on the top. And what about the y's? They go away. And what about the z's? 2 on top. And since I don't have anything left on the bottom, it'll be just 3x z squared. You've done this in Algebra 1. So at this point, we're not really learning anything new. It's just a review. Okay? Here, we can do the same exact thing. But first, we have to factor anything that can be factored. We're good with the numerator, so I'll just copy that over. And here I have y times y minus 3, y plus 2. All right, so we're just factoring out the y squared minus y minus 6. All right, once you do that, the y minus 3's will cancel, and so will the what? So will the y's. So I have 4 y plus 4 over y plus 2. Make sense? No. Okay. Now, sometimes when I have an a minus b in the numerator and a b minus a in the denominator, I can cancel them out. So how does that work? Suppose you have a minus b, right? And suppose I wanted to factor out a -1 out of this, right? So if I factored out a -1, what do I get? What would the a turn into? Negative a, and it would be plus b. Okay? Because I'm dividing both by a minus. So this will be minus, and what if I were to like swap the order here? B minus a. Okay, so look at what I have. I have that a minus b is equal to b minus a with a negative out front. Okay, so if I have a minus b and b minus a, I could cancel them out and it'll just turn into a -1. Okay? All right, let's just apply that here. We're going to try to factor this first one. What can I factor out? A to the what? To the 4, and I get b minus 2, and a cubed, and I get 2 minus b. Okay, so now let's just take care of the a's out front. This and this will give me just an a. Now, what about the b minus 2 and the 2 minus b? Can I cancel those out? I cancel those out and I get -1. So I put a negative out front. So the answer is just -a. All right. What are we going to factor out from the top? An a and a b. And we have b minus 5 left. On the bottom, I have 5 plus b. 5 minus b. What can I cancel? right? And I have to compensate with a what out front? A negative, right? So this is going to be negative AB over 5 plus B. Okay? Questions? All right. All right, so how do we multiply and divide? Okay. What I like to do is convert all of this so I have one major fraction. So I say equals to and a fraction line. Now what do I have in the numerator? I have an 8x and a y squared. So basically I'm just consolidating, okay? And on the bottom, I like to write my coefficients in the beginning. So I have a 21 times a 16. So I'm just like collecting them out front. And I have an x cubed and a y cubed. You could do y cubed, x cubed too. I just like to do it all in the same order. Okay, now, between the 8 and the numbers in the bottom, right? 8 and 16 can be simplified. I can divide by 8. I can divide by 8. So I get 1 and 2. So I have a 2 on the bottom. How about my x's? How many on top? How many on the bottom? Oh, there is a 21 on top and the bottom here as well. How many? There is an x squared on the bottom and 1y. If there is nothing in the numerator, we put a 1. So this is 1 over 42 x squared y. Okay, questions? All right, now, what if we have to divide? Right, it's times and then we flip, just like the way we learned back in the 5th grade and the 6th grade and through Algebra 2. Same mathematical rules apply. So this is going to be 10mk squared over 3c squared d times 6c squared d over 5m squared. Now it's transformed into the same type of problem as part A. So I'm going to give you 2 minutes to work through this on your own. I'm going to stop the recording for 2 minutes. I'll get to it. So once you have everything in one fraction bar, then I reduce the 10 and the 5, the 6 and the 3, and those give me 2 and 2. And then I just go through and cancel out the variables. Any questions? Huh? In the end, you still have to reduce, but then you will have like 60 over 15 to deal with, as opposed to, you'll still get a 4. You have to reduce at the very end. If at the very end it's still not reduced, that means you haven't completed the problem, so you can't get full credit. Okay? All right, so this one, I have a k minus 3. All right, so look, I'm going to combine everything in one fraction here. Okay? I have a k minus 3. Now, can I factor that? 1 minus k squared? What do you guys think? How about this? Can that be factored like that? Yes? On the bottom, I have k plus 1. How can we factor this one? K minus 3, k minus 1, right? Okay? So we factored. This is why we go through chapter 5, is because now we just need to be able to factor so quickly so we can move on with the problem. All right, what can we reduce here or cancel out? K minus 3's. What else? K minus 1 and the 1 plus k and the 1 minus k will cancel, but what do I have to do? Negative, and what else cancels? 1 plus k and k plus 1. Do I have to do a negative for that one? Not if it's plus, so the answer is minus 1. Who would have thought? Such a cute little answer from that one, right? Okay, we're factoring here from the first one. I factor out a 2 over d plus 3. No. D plus 2, d minus 1. Right? Yes? Okay, so this is divided by d plus 3, d plus 2, d plus 1. Now I need to switch the second one. If you wanted to switch from the very beginning, totally fine. Okay? So this is 2 times d plus 3, d plus 2, d minus 1 times, we flip, now if you're comfortable with doing some things mentally and going from the first to this step in one step, that's totally fine if you want to skip that intermediate step. Okay? All right, now here's another thing you could do to eliminate some work. You don't even have to put everything in one fraction bar. The rule is whatever is a numerator can cancel with something in the denominator. Okay? So I have a d plus 3 as a numerator. Does that cancel with the d plus 3 down here? Sure it does. It doesn't have to be under one fraction bar. What else can cancel then? D plus 2. Anything else? No. So what do I have in the top? Let's collect everything we have in the top. 2 times d plus 1 over d minus 1. So I like to show you guys the little itty bitty shortcuts because you know what? It's all about efficiency. If you want to do everything like, written out, and all the more power to you, there is a possibility of skipping some things sometimes. Okay? All right. 2 more. 2 more and we're done with this section. You will never know. Okay. Here we go. Take a look at what I have here. I have a fraction, 9 over 8, divided by another fraction, 3 over 4. My experience is a student sees something like this and they freak out. And then the teacher tells them what a fraction like this is called, then they freak out even more. What this is a fraction within a fraction. Mathematicians call this a complex fraction. Not because it's difficult to solve, it's complex because it's nested. That's all. They could have called it a nested fraction, then less people would be scared. Okay? But a complex fraction is just a fraction and a fraction. Now, once you get over that fear, okay, and you step back and you go, oh, this is just 9 over 8 divided by 3 over 4. And then you go, oh my God, that's not so bad at all. This is just 9 over 8 divided by 3 over 4. Do you see how those two are the same? Okay, so now I'm going to show you the one method to do it, and then I'm going to show you the second method to do it. So this will just be 9 over 8 times 4 over 3. Divide by 3's, you get a 3 here and a 1 here. Simplify by 4's, you get a 2 here and a 1 here. So this will be 3 over 2. Okay, this is still the same as what we used to do like in the 4th, 5th, 6th grades. Okay? Now, method 2 is this. This is how I would like you to start doing it as we reach the end of Algebra 2 and as we near the beginning of pre-calculus. Okay? These two are the outer terms. Does everybody agree? Okay, so I could do the outer terms divided by which, do you think? Oh my gosh, how did you know? This is so much more elegant, especially when you deal with ones like B, okay? So this one, does everybody see that we're going to get the same answer? Oh my gosh, magically, it's 3 over 2, okay? So this is how I would like for us to do it in the future. And if you ever want to get invited to all the cool math parties, you're just going to have to know this, and that's the end of it, okay? Now, let's do the next one, okay? We're going to do it in this new and improved, with this new and improved method. So I draw my main fraction line. Now, I'm going to do outer over inner. What's the outer? X squared times 2y minus 3x over, what's the inner? X cubed 9x squared minus 4y squared. Okay? So yes. Yes. Now, can we cancel out these x's, those pesky little x's? Yes. How many will remain on the bottom? Just one. So I'm going to have 2y minus 3x on top, 1x on the bottom. And now, can I factor this one? Is 9x squared a perfect square? Is 4y squared a perfect square? Yeah? So can I factor it like this? Where I do the square root of the first and the square root of the second? So 3x minus 2y, 2y. Now, anything to cancel out here? It would be plus minus. Thank you. Okay, anything I can cancel out? Yep, I can cancel these out, and what's the price I have to pay? Negative out front. I don't really have much left in the numerator, so I need to put a 1 as a placeholder. And I have x, 3x plus 2y. We're good? You can, but we don't, because the point here is to just factor. Okay? So that's that. Before I take questions, this homework will be due the Tuesday after the Shabbaton. So this, oh no. Yes, because we don't meet tomorrow. Okay? Huh? It's due Tuesday.